This is Mrs. Cahill with Lesson 9.1, Scatter Plots. Let's construct a scatter plot. So data with two variables are called bivariate. Two variables, they're bivariate. A scatter plot shows the relationship between bivariate data graphed as ordered pairs on a coordinate plane. For example, the bivariate data set year and number of visitors can be displayed as a scatter plot. So we're going to take our two sets of data and plot them on the x and y axis. So this is bivariate. Construct a scatter plot of the number of viewers who watched a TV season of a certain television show. So we know the x values go here and the y values go here. Our x values are a number of seasons and our y values are our number of viewers. And notice x is here and y is there. So we know how to fill this in. X is our seasons and y will be our viewers in millions of people. Okay, so now we're supposed to graph this data. So I know that season 1 had 31.7. That goes right about there, just under 32. And for season 2, 26.3. And season 3 had 25, and so on. And it's as easy as that. You can do it. Pause the video, and you try this one on your own. So you're going to construct a scatter plot of the weight of an alligator at various times after hatching. So at week 0, well, we know our weeks are going to be our x and our weight will be our y. And we can just plot the points. At 0 weeks, we are at 6 pounds, and at 9 weeks, 8.6. And you kind of have to estimate your points to the best of your ability. 34 weeks will be at 15. We get them all in there, and you've done it. Easy peasy. All right, types of association we can have. So look at these graphs. We'll look at the first one here. The variable association, what do you notice? Well, that line's going uphill. That's a positive association. It's uphill. What that means is as x increases, y increases. The next association is negative. As x increases, y is going down. And in the last situation, the dots just look like they're all over the place. There is no association. There's no pattern. Linear association. So after we look at whether it looks uphill or downhill, we can decide if it looks linear. Notice in this first graph, the data lie close to a line. We could say that that's linear. And in the second set, it's not quite linear. It's more of a curved shape. So it's nonlinear. Now let's look at this graph here. And that does appear to be linear. But what I want you to notice is first this point way up here that's separate from the rest of the data. We call that an outlier. And down lower, we do notice a set of data that seems to be clustered. And so those are really close together, and you would point that out when you're describing what you see on a graph. All right, let's look at example 2. You're going to interpret the scatter plot of the data for the amount of memory in an MP3 player and the cost based on the shape of the distribution. So our bivariate data, our x is memory and our y is cost. So what do you notice? Well, as memory increases, the cost increases. So we would say that's a positive relationship. That's the first thing you've got to tell me is it uphill or downhill, or neither, but in this case positive. Also, the data does seem to lie close to a line, so we would say it's linear. It's not curved, it is linear. And we do have some clusters. You notice with memory, you can only get it in 1, 2, 4, and 6 gigabytes. There's nothing at 6 or 7. It only happens at those numbers. If it were to go on, what you do is you double. The next one would be 16, and then 32, and 64, and so on. So it clusters. That's how memory works. All right, you try it. Pause the video and see if you can interpret the scatter plot of the data for the time elapsed and the temperature of water based on the shape of the distribution. So go ahead and pause. Well, you'll notice that as time increases, that your temperature is decreasing. we say that that is negative. That's the first thing you've got to point out to me. Now, does it appear to be linear? Yeah, I can roughly put in a line there. They lie pretty close to a line, so we would say it's linear. Do you see anything else strange? Are there clusters or outliers? I would say no, not in this. So those are the three things you need to answer. That there's a negative association, that it's linear, and that there are no clusters or outliers. Those are the three things you need to answer each time on these questions. So you try this next one. You're going to interpret the scatter plot of the data for 2 weeks in May and the amount of ice cream sold at a shop based on the shape of the distribution. So pause the video and make your attempt. All right, did you notice there appears to be no association at all? The data points are all over the place. So we would say no association and not linear. Well, non-linear, and no clusters or outliers. So it does not association. Those are the key things you need to tell me, and no clusters or outliers. All right, example 3. The data shows public school enrollment from 1999 to 2010. And our X value will be our years since 1999, and our Y value will be our number of students. Now, they ran out of space, so they continued the table on this way. This really should be all one big table. Notice that we don't say the year 1999. It gets kind of big on the graph. We call that year 0. So the year 2000 would be the year 1, and so on. We're going to construct and interpret a scatter plot of the data. If an association exists, we'll make a conjecture about the number of students that will be enrolled in the year 2015. So this is a new part. You've never done this before. Make sure you pay close attention. So let me make that smaller, and I've got my graph paper, and we're going to plot those points. So if I plot those points, and you know they're already plotted, right? All right, there they are. And hopefully you can see that at year 0, which is really 1999, we're just below 47. And at year 1, we're at 47.2, so just above 47. And I have no doubt you can plot this data yourself if you needed to. So now let's talk about the variable association. That's if you tell me if things are positive or negative. Well, you can see that's uphill, isn't it? So we would say, hey, as the years increase, what's happening to the number of students? They increase. So we would say it's a positive association. That's number 1. Telling me if it's positive or negative, or neither. Sometimes it's neither. Linear association. Could we put a line on that data? Well, sure we could. There's my best fit line, which is, by the way, another lesson, but that's okay. So yeah, there's a linear relation. It's not curved, it's linear. Any other patterns? Do you see anything else? I don't see outliers. I don't see clusters. Okay, now here's the last thing they asked us to do. Let me scoot up here. They said, hey, if we saw an association, we've got to make a prediction about the year 2015. Notice our data didn't go that far. So the year 1999 is year 0. So the year 2015 minus 1999 is going to give us 16 right here. So we want to make a conjecture. Now I wish my line were longer. And where's it going to hit? Let's go see. So at year 16, well, I hope the answer on the book is right about there. Now my lines are a bit squiggly. Let's call it about 50 million. Let's go see what they say. To make a conjecture about the number of students that will be enrolled in public schools in 2015, follow the pattern. So we did. We continued on with that line that we had until the X value is at 16. We did that. Find the corresponding Y value. So there appears to be about 51 million students enrolled in public schools in 2015. And if I had been neater, I might have hit that number. And we're all going to get slightly different answers depending on where we put our line of fit. But I could see that that could potentially be my answer, maybe 51.5, but we'd be close. All right, now I want you to try this one. You're going to interpret the scatter plot shown for the men's Olympic 100-meter freestyle swim winning times. If an association exists, make a conjecture about the winning time in the 2016 Olympics. Make sure you answer everything. Okay, so I would say first, there is a relationship and it's negative. As the year increases, the swim times are decreasing. There don't seem to be any clusters or outliers, so make sure you're doing all these parts, guys. It is linear, and so we can now figure out what's going to happen in 2016. Notice here we're counting by eights. If this is 1992, and this is 2000, this is 2008, so 2016 would hit right about here. How high is that? Well, the book said they had it at about 46.5. I'm okay with that, and that would be the winning time. All right, you are set. You've taken your notes. You can go to page 670. Notice I have not assigned many problems. That's very few. So that means you are expected to slow down, take your time, watch this video again to make sure you understand how to answer all the parts. Each one of these questions has multi-parts.